Hello again, everyone. Nice to see you. And we're in the Joy of Functional Game Dev Project 2, Episode 3. The tag at the start of the episode in the GitHub release is v0.2, end of Episode 2, start of Episode 3. In case you're following along as we go. Alright. So, enough about that. We're now going to go over to Trello. When we last left our hero, we were in the midst of some window renderer basics. We wanted to get window flags enum, creating a renderer, destroying a renderer, and waiting for an event, which basically gives us the main event loop for any SDL project. And a solid point where it's like, yep, we've planted our flag in the land of SDL, and we can just start conquering from there. I suppose we could start with the Windows flag enum, because that'll be right here, I think. Yeah, here they are. All the SDL window whatnot. And we will just copy those right on over. There's an actual enum. And before I just used the values. And I have to decide, what do I want to do with this? Of course, I can always go with an enum later, but I think I want to continue on the way that I did. So I'm just going to copy these over. And we're going to go right here into SDL window.fs, and we will shift tab. There's going to be a lot of lets going on here. And while we're at it, we also got to get rid of our commas. Oh, there's a comma way over there. And we also need to get rid of. We're going to get rid of das. And we're going to replace it with eh. Okay, no more occurrences, and I want to take slash that, this with and all of them. 14 occurrences replaced. I want to go back to the literals page. I need to learn. This is a thing that I don't know. This is a thing I now need to know. So my S bytes, my uint32s are U or UL. So alright. Rather than, as is the case over here in SDL, so I don't need to do this. I can say U, and it's the same thing. I think I like this better. Or do I not? I'm not sure. I'm not sure how I like it. But it's just part of the language. So they uint32. So that's how we do those. So these we all use. We have to have 3 of those and a U. Yeah, nothing quite feels like it's wedged into a language like having 3 pipes to mean bitwise OR. It's like, we need bitwise OR, we want to use the pipe. what'll we do? Oh, I know. We'll use 3 pipes. It's okay, not the strangest operator in there that I've seen. There's a casting operator that I found particularly bizarre. Yeah, not that operators are what operators are, and it's just that they come from a very imperative C++ background. Actually, originally Pascal, but so I'm used to strange operators because in Pascal colon equals was the assignment operator. So I'm okay with operators not making a whole lot of sense. Well, this makes for wonderful stuff going on here. See, that's the thing. Once you start lining things up vertically, you're done. You will. Let's go. You will dude fuss your way all day long. So these are my values. That's nice. All right. So now when I pass flags, I can say one of these. These are my public ones. And my window type is an int pointer. I'm going to create windows. Alright, so we got that. So in our program, we'll just say window shown. SDL window shown instead of SDL window shown. These probably need to be renamed, but well, that's really kind of a balancing act when you're making a binding. You are in a way catering to the people who already use the API, the SDL API as it is. And the thing is, you don't want to have to have, I don't want to have them completely relearn how to use SDL. So leaving those things there is sort of a helper. Even though some of what I'm doing, like especially in SDL window.fs, I am causing a little bit of change in how they do things just by putting these in modules. But rather than SDL create window, it's SDL window.create. So there's, I don't know, it's a balancing act, right? But the constants I'm going to leave as is. That way, if you're porting something over, the constants, which are always these huge long things, you don't have to figure out which one you got. That's my story, and I'm sticking to it. All right. So we're creating those things. We need to also create this thing called a renderer. And all right, so create renderer. And these are, let's go look at the actual source code, because we have SDL render right here. Let's find you SDL render, create render. Create renderer. So this is our guy. We want him here. We want him in SDL render. Module SDL render native. Let's call it render, SDL render. Yeah. So that's that guy. We need that one, and we need destroyer render, naturally. So we need the bookends. We're going to allocate it. We're going to delete it. Then, of course, CL destroy renderer. That one's pretty straightforward. This time, let us not forget that we need pretty much these guys right away. And also we need our DLL import decorator. So there's that. And of course, decal spec goes away. This DL call goes away. SDL renderer star becomes an. Well, let's take a look, because this is going to be interesting. Because there's is this going to be just another, hey, here's a looking for SDL renderer. Okay, so it is struct SDL renderer, and it's a pointer to something, and that's platform specific. So from our point of view, it is nothing but an in pointer. So we're totally okay with that. And so similar to the way we do window, similar to that, a renderer is nothing but an in pointer. But actually, it occurs to me that this can be a window, and that can be a window. Since an in pointer is a window, and I can better show through signatures here. That's renderer. And so we need an SDL window, which means window goes up this way. I don't strictly need to, but since I wish to use SDL window, it's an int that, it's a uint32 flags. Those flags are a see, and here's a very big chicken and egg thing. I know there's a function called create window and renderer. Where would you put that? Would you put that in window? Would you put that in renderer? And if so, how would you resolve the dependency? Well, you would probably put your render in window in like an SDL types thingy. Not that it really matters. They're all int pointers anyway, and it's all moot. But alright. So we need a window, we need an index, and we need flags. And my flags are... So if I look for SDL create renderer, all these lovely things. So my index, or need one, the first one's supporting the requested flags. Okay, just -1. So, how very C of us. Just put -1. It'll be okay, obviously. Yeah, because here's this create window and render, but it's in SDL render. I don't know. This is obviously the one that we would want to use. There's render drivers. So this is the, hey, give me the drivers that I can use for this stuff. So, info. These are my renderer flags. I'm going to need them. Okay. There's not much to it. I suppose not. Alright, well, let's get these in here. I'm gonna replace the... So like some special signal to the documenter to say, hey, do cool stuff when you see one of these guys, because it certainly looks like it. It's not one I'm particularly familiar with. I'm going to get rid of the commas, make them nothings. And do a let. Make them into U's. Make everything line up vertically. At least these are... Oh, nope. At least these are it's a shorter enum. Alright, let's get rid of that. Why we didn't go further on the line, I don't know, whatever. What do we not like? Spread, oh, comma. Comma. Oh, we got rid of all of my commas. Derp. Got rid of all, I no longer had a selection. Go me. Okay, so now we're cool. So now we can create a renderer, destroy a renderer, and somewhere in our program, let main window equal that, let main renderer render. Oh, we didn't make our wrappers yet. Okay, let's wrap them. Let create index int flags unit 32 and return a renderer. And we're just going to call SDL create SDL render native. Create the renderer. Oh, we need the window. Window. Do it with the window. Oops, SDL render. SDL window dot. Fully qualifying things. Alright. So SDL create window. Create render window. Index flags. That's gonna do for that. Let destroy render. It's gonna return unit. It's in SDL render native. Destroy the renderer. And we are cool. Now we should be able to create the renderer and destroy the renderer in our program. Create main window. There's one. SDL renderer. Oh, it's just SDL render. And I obviously want an accelerated one. STL render, destroy. I suppose I want main render. I want to do it that way, of course. I want to do it that way too. I want gonna work? You're gonna work. What the? Ugh. When spaces are syntax. Yeah. But I'm just curious about that now. Let me look at that again. One little space causes what? Me to think that yeah, that's a that Alright, moving on. Make sure you line up your stuff there, everybody. So now, in theory, should be able to, if we build. Now, of course, what does it say about destroy renderer? Function destroys render for a window and free it. So I don't really know what order it should go in. Let's take a look over in Windows. Create window. I want to look at destroy window. Does a destroy window also destroy its renderer? Yeah, I don't know. Well, we're going to see what happens. I'm guessing that you probably want to, if you're destroying the render, you want to destroy it shortly before you destroy your window. Just a guess. Okay, we're going to make a main window. Main window made. Going to make your main renderer. Main renderer made. Going to destroy the main renderer. Main renderer destroyed. And then the main window also destroyed. We're going to quit. We're going to go to the place where I can talk to the console, and we are good. As near as I can tell, we are creating, destroying. We did the Windows flag enums. We also did a renderer enum. That one was a lot less lengthy. Now we are going to wait event. Alright. We need event handling. We have SDL event. And where's my keyboard support? There's all sorts of, well, let's take a look. I got SDL event in here somewhere? No, I do not. Let's go find it. Got my include SDL event. SDL events. So let's go look. There's all kinds of these things. There's event type. Common event. Window event. Keyboard event. Text editing event. Input, mouse motion. Oh my. Yeah, this is going to be one of, I remember now. So, yeah, this is, this is a union. No. that's going to be an interesting thing. Because, well, ultimately, we do want some sort of discriminated union, because that's how we want to do our events anyway. But the padding 56, ABI compatibility, 2 bytes, and UCC will use the 11 largest data type, so we'll add padding to force. Huh, alright. That's good to know. This is actually the most useful thing I've seen today. And it may be key to how we decide to read things in. So, the biggest okay, if you never used a C union before in your life, it's in essence similar to what we want to do with a discriminated union, except that rather than part of the value being which one of these we're using, all of these are valid at the same time. And so what they would do is they would put something like a type variable, and if you go look at any of these, the type variable is the first one there. So it happens to overlap. So you can always look at type and then use it kind of like a variant. In our discriminated union, it's a lot safer, for one thing. And these were commonly, these are one of the this will be the second most common, well, second most abused thing, because there's like a variant type, and if you weren't careful, it's almost as bad as buffer overruns, the way that you would do these goofy things. But so each one of these takes up the same amount of space. You can interpret it as just a uint32 or an id as any of these, but in the end, you can use it as an array of uint 8s. That's 56 uint 8s. So 56 bytes. We know this is 56 bytes. We can always read 56 bytes, and that is going to be very useful for us. But we can also interpret it as a single uint32. And so for now, we're going to look at, do we have SDL wait event? SDL wait event. And that's going to be an interesting thing. So it fills out a structure, or it fills out something, and that something is going to be an array of 56 bytes. So how do we get that? Module private SDL event native equal that. Well, let's start getting it done, because the sooner we get to that, oh, not there, those. Get our little DLL import in there. So we want to get rid of these things. And at the moment we can say it's an int pointer, but we need to make sure that that int pointer is a byte array that contains 56 bytes, and that we can then later interpret. All right. And more importantly, importantly, I do want to be able where'd I go? SDL wait event. Where you at? Okay. I want to be able to do this, but I want my event types. I need my event types. Unused but do not remove. It's to make sure that other things that you have to do to force the C and C++ compiler to do stuff. More or less, the only thing we're going to first even deal with is the SDL quit. So, and we'll get these in to be sure, but for now, we're going to bring SDL quit into here. Let SDL quit equals 0x100u, and that's what we know. That's what we want to know about. So I need a byte array, and I need to pin it, and I need to get it out, and we can at the very least do that. But then how do I get out whether or not I get an SDL quit? Well, let's worry about that. Let's worry about that in a minute. So let wait event, and wait event, what does it say? It says it returns an int. So relay, where did SDL events go? SDL wait event. So 0 if there's returns 1, or 0 if there is an error. Prime event, if not null, the next event is removed from the queue. Okay. Then at the very least, I'm going to make a byte array. All the wonderful fun things we get to learn. This is so wonderful. So what I have to do to pin the array. So I have bytes. I want to make a byte array 56 bytes long. I want to pin it with a GC handle, a lock, and pin these things. So I want to do something kind of like this. I'm going to copy and paste this to the place where I kind of need it. Even though I don't exactly use this. So wait event equals, I need a byte array, so F# create array, well, create byte array of a particular size. Create a byte array with a particular size. Array.0 create 10. There's a 0 create. That's awesome. Array init 10. Or I'm not completely opposed to this. Let's do that. I can do this. I don't know if it's got a check mark. It must be right. So let bytes equal 0 to, it's 55. We're going to have 0 UI. Yep. Yeah. Well, we want to leave spaces and whatnot. So it's byte array. We're going to pin it. We're going to free it when we're done. Now what we're going to do is we're going to SDL event native SDL wait event. um, pinned array dot address of pinned object. Do I have to let them be mutable? I think I have to let them be mutable, right? Let me put them. Okay, and it's going to okay, let result. Okay, and that's going to be an int. And what does it return? 1, 0 if there's an error. Okay, so so if it returns a 1, I'm going to return, so I'm just going to say equals 1. Alright. No, that's not how. That is not totally not how I want to do it. If result equal 1, then some bytes. Else, none. So, wait event returns a array of bytes option. Eventually, it will return an option of a type that bytes gets transferred into, but for now, yeah. So wait event gets an event, and you got to do something with the event. So if this works, just going to go while stl event dot wait event. I'd rather do a fold, I guess. So I need to find some way to fold. I really do. Is there an option dot fold? Tell me there's an option dot fold. There is an option dot fold. Does it do what I want? Because really what I want to do is I want to have some sort of value that keeps folding itself. So I'm going to look up option fold right quick. Option fold. But will it only go through the once? I don't want scalar. Come on. Does it just fold through the whole thing? Original state if the option is none. Otherwise, it returns the updated state with the folder and the option value. I think I need I need to do a recursive function is what I need to do. Okay. Let rec event pump. Yeah, I have to do it this way. We'll go with a window renderer. So we're going to let event equal event dot wait event. Match event with some X. Gonna do something. But if we're gonna match with none, then unit, I reckon. So some, and that'll be some X. It'll be event font. Okay. So now, when I get an event, I'm going to wait for the event, and then based on the event, if I get none, I'm going to have an error, and I'm going to exit out of the event pump. And then this is going to be a I'll handle whatever. I'll go if it's a. But all right. Will you work? So then we're going to event pump. Okay. So we'll event pump it, and then when we're done out of the event pump, we will go there. And this is kind of how I'm going to have to do this. Because there isn't really a structure where I can fold. I need to keep it going. So recursive function, the only way. Sounds crazy, doesn't it? Okay, main renderer. Just going to. So what does event say? What is an event? It's an event. So 0, 2, 0. I don't even know what these things mean. So go. Alright. Yep, that's a window. I have no clue. Huh. Now, ideally, the first four. So suppose console dot. System.console. We're gonna bring system in. All right. Hey, I ain't gonna do none of that. Open system. Console dot write line event 0, event 1, event 2, event 3. Hi, welcome to F#, where we use dots in order to get to our arrays. Is that right? No. But ooh. I'm gonna do an if. I'm gonna do if event is some, then that, else do some nothing. Alright. I just don't feel like it today. Okay. Despite gonna work, you are gonna work, aren't you? Okay, I want this guy over here. We need to continue. We need to see him. 4. Boop, 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 boop. think I need a border or something. I think I got some. I'm going to guess little endian. So, let's look at the events, and let's make an assumption that something that starts with 4 will be the mouse motion events. So, the 0, 0, and then the 4. So, but then also, let's try to get some sort of, I'll have to do some of this, huh? Ugh. Get you on. Where? Window. Here's my. Is there one for a border? Not borderless. I don't want borderless. I want. Sizable. Not borderless. I don't want borderless. Which one do I want? What resizable? Oh, I guess not. Oh, I get a little guy here. Alright. So what I want is I want SDL2 window with close button. Create window. Is there? Well, here's this. These are remarks. Let's look at remarks. No window decoration, but I want window decoration. Oh. So I guess my window shown doesn't really matter. Drawable size, get render output size. How to make SDL2 window with a border. Don't want a borderless window. I want a stupid, I want a window. Yeah, see, I was just there. But what that means is my, I guess I need nothing. 0, U. Boom. So 4, 1, 4, 2. So I'm going to make it. If you click the window, so if I get a 2, 4, then we're going to quit. That's what we're going to do. If x dot 0 equal to and x1 equal 4, then else. So now equals to UI. So now, once I release the mouse button, it should close. And that gives us enough of a something. So, neat. What did we just get? We just got 2, 4, and then what? We just kept going? What happened there? Oh, did we actually Did we quit at that point? Hold on. I'm curious. So, I start. So I click the window and then it goes away. Click. And we're done. Alright, that's cool. I think I want to do a console dot. Do a print fun. Window. Just all done. Press any key. So that's all cool. So don't. Oh. All done. Neat. Okay. And that is actually quite an accomplishment for one day. We don't want to do that anymore. And this is cheesy, but we're just proving, hey, we can get an event out of the system. We need to be able to map it into a real discriminated union, because that's going to be the next little step here. Because we certainly want to differentiate on it, but we want to do it in an F-sharp way. We don't want to just have a thing of bytes. I mean, this is cool and all, but let's get it done the right way. So, all right. So to handle a line. So it's just an object. And it's pinned. Can we? This is. Now, can we do things? Yeah, not sure. So how I wind up? I'm gonna have to learn more about copying bytes. I think I need to copy bytes from something to another something, and this is going to be an insanely complex looking function that hides this stuff. But we will figure it out, and we will have real we will have real events. We have real events now. It's just they're kind of painful to find them. So then after, all right, so that's cool, and we got some good stuff done. Let's get back over to Trello, because in Trello we are waiting for an event, and that means we have completed that. We're done with you for now, and that's cool. Done with that. Can do initialization shutdown, but I don't plan on. We're currently just using videos and events, and so that's one of those things where a little bit later, put that down here somewhere, because we know what we want to do and how we want to do it, but we only have the one video subsystem, so we don't exactly want to shut them down yet. We don't need it. So next up, we either have display and window management again. I want to draw something. You want to draw something? I would love to draw something. So let's take a look at surface creation and simple drawing. We'll probably have to do something with rectangle functions, and there's also a possibility that we need to do some pixel format stuff. Event handling we will leave as rough as it is, and I don't know that we're gonna tackle that just now. We're looking for a pigeon on can we get anything at all to the screen, and the sooner we get to that, the better. But it's nice because, and also what I really like is we now have a because here's this. I got a console and an SDL window. I think that's pretty cool. So I can look at I can write stuff to here while there's stuff going on here, and then later when I want to get rid of it, I just say it's a Windows app. At least let's make sure I'm not lying to you here. So I just say I'm a Windows app, and suddenly, yeah, suddenly I don't have a console anymore. So that is quite handy. Yeah, try that with try that with C++. That wasn't the way of life there. We're going to put it back to console app though for now, because we like that functionality. Anyway, hey, we got a window. We got a window. We got a render. We're ready to render something, and we can, in a very roundabout way, we can at least see the contents of events. Yes, we have to look at them as bytes, but that's not nothing. That is something. And thanks for coming along on this journey with me. And this is I'm learning a lot here, and I hope that you are too. And there's a lot of weird cobwebby looking stuff here in .NET to do these sorts of things, and then even into a language like F#, which is, supposedly kind of above all of these things. You could still get down and dirty with a native library, and it is painful like this, and I think this is going to get a lot more painful. But so cool. We will see you next time, and just keep experiencing the joy of functional game dev. See you next time.